So, again, we're ready to go. We will have the tale of 10 years of emulating the Nintendo 3DS with ninjas, lemons, and pandas brought to you by neobrain, a software developer, all into compilers, device drivers, kernels, and virtualization. And he's here with Mikage, a whole platform 3DS emulator with a focus on high accuracy as well as performance. And you may also know his other projects, Dolphin, PP, SSPP, and Citra. So, we are not only having fun while playing games, but also emulating them. Then, let's go.
Thank you, and hello everybody, thanks for coming, despite the technical troubles there in the beginning. Yeah, everything's been said really, but still a little overview about what I do. I started emulating or working on emulators in 2011 or 2010 when I played Super Smash Bros. For the GameCube for the second time after playing it on the physical GameCube. But then later I tried it out in Dolphin and played it at glorious 5 frames per second. But I was completely blown away by just like asking myself, how could this possibly be working, emulating such a complex console on regular hardware. And so I just went from one challenge to the next one, always trying to find something new. The cool thing about emulation is there's always something you haven't done yet. And so in 2013, my, to that day, biggest step came across when I started working on Citra together with somebody I knew from a different project. And that got a little bit too successful for its own good, so I basically started over in 2016 with my now still in progress 3DS emulator, Mikage. But I don't really want to talk too much about myself. I want to talk about this little thing here, the Nintendo 3DS, released back in 2011. It's the successor to the Nintendo DS. A lot of people mix these up. The Nintendo DS, that's the one that had 2 screens for the first time. The Nintendo 3DS, that's the one where they added a stereoscopic 3D display at the top. Just to throw some numbers at you, this thing is packing a collection of 4 ARM11 cores running at 800 million operations per second. There's a fairly unique GPU, which is not in fact in-house designed, but rather created by a company that was a university or academic offspring. And as far as I know, the 3DS is the only console where this GPU shipped in such high volume numbers. It's basically an OpenGL level, OpenGL 1.1 level piece of hardware, which was already fairly outdated around 2011, so they tacked on a couple of fixed function extensions on top of it to bring it to the state of art. There's also a dedicated audio processor, the DSP, Sivatec Lite 2, which we'll get to in a moment. And the whole thing packs about 250 megabytes of RAM, as well as some helper memory. If you want to learn more about the ins and outs about the 3DS, there's a really good overview article written by Rodrigo Copetti. Definitely recommend checking that out if you're interested. But how about the actual software running on the system? So most of you might know the home menu, which was the hub where you can launch all of your applications, notably games, of course. But also you can download new applications, new games from the eShop. You can configure the system, you can use a web browser, fairly interesting, especially if you want to run WebKit exploits on it. And there's an AR games application and other toys like that. There's personalization things, the Mii Maker, and social features like the Friends list or the Miiverse, Nintendo's very own social media network. Oh yeah, and nowadays, of course, we have our own little way to run code on this thing, the Homebrew launcher and a wide collection of libraries to facilitate writing your own homebrew applications for the Nintendo 3DS. From an emulator's perspective, this is kind of superficial, so let's actually look what's happening between those 2 layers. Because on the 3DS, the games do not run on bare metal hardware anymore. Instead, there's a full-blown microkernel in between those 2 that takes care of things like memory management, multi-threading, process isolation, all sorts of things like this. And also, whenever you want to access any specific piece of functionality, like graphics, internet, or just plain file system access, there's a set of around 50 different modules that we call services, which basically separate these different concerns for security reasons so that, for example, if we hacked into the graphics driver, we wouldn't be able to do anything that more privileged modules can do. Those service modules, in turn, they actually get access to a second world within the kernel, which is a more private, more privileged set of APIs that games don't normally have access to. And there's a whole coprocessor on the system on chip, which takes care of the really confidential stuff, such as signature verification and generally making sure that, you're not running code on the system that Nintendo didn't sign off one way or another. Yeah. So that aside, how did we get started? Well, you might know there's a small timeline display up here. It actually took quite a while for us to get off the ground because the homebrew community itself needed until 2013 to really figure out how to break into the system and do cool things with it. And so in the beginning, we worked off of simple homebrew applications, that's like Pong clones or Tetris clones. And we basically took these homebrew applications and took an existing ARM emulator core, bundled it with an ELF loader, and wrapped the whole thing up in a debug GUI that we had from a previous project. And we just tried it out and saw what came out of it. It was really a stretch to call it a 3DS emulator at that point. It's more like an ARM emulator, a GUI, and an ELF loader wrapped in a trench coat pretending to be a 3DS emulator. But it worked. We got more and more things running. And eventually we got to the point where we decided to actually go public with this thing already, even though it was very preliminary. But it was enough for us to get a feeling of just generally how the system works, and in particular how the 3DS kernel is functioning and what we need to do to emulate it. So yeah. It's worth noting, none of these things here use the GPU at this point. It's all just a CPU rendering into a frame buffer. So what's up with the GPU? Well, it turns out there was no homebrew that actually used the GPU, so there was nothing for us to work with. Until April 2014, when Smelum, who some of you might remember from a couple of years ago from this stage, he managed to create a homebrew program that created a spinning cube on the 3DS, which, for actually getting something up and running, that's super exciting, even fairly boring for users. But as soon as he got that running, he sent me the executable and said, okay, I'm handing this off to you. You can now implement GPU support, etc. I was super excited. So to get started, you have to consider that a GPU is a fairly complex piece of hardware. There's so many different stages that each do their own specific thing, and they're arranged in a pipeline, which means that to get anything on screen, you need to implement every single process of this pipeline. And especially just the command parsing is something where the emulated game sends us a pointer and a size, and that's it. So we kind of need to figure out what all this data in memory, it's just bits and bytes, right, does, and we need to structure that and figure out how to implement it in an emulator. So the first thing is I just started writing more and more debug widgets. The details aren't really all that important, but what matters is that you have this view here where the binary data is actually grouped in different commands, and those commands can be labeled with the thing that we eventually figure out they're doing. So you can see that this is already tremendously better than just looking at a hex dump. And we just basically added more and more structure on top of it. So eventually you get to the point where it's executing a vertex shader. So you write a vertex shader disassembler. They start getting submitted textures. So you need to write a texture decoder. And the whole thing gets more and more complicated until you get the whole picture eventually. And once we did all of this, we had a fairly good understanding how it worked, and we could actually sit down and implement the emulator itself. So we started with a software renderer for flexibility. Starting very basic, spinning cube, yay. More spinning cubes. Texturing with cubes. And finally, after 8 months of work, we actually got the homebrew Minecraft version, also written by Smelum, running in its full glory in our emulator, Citra. So that was pretty rewarding for us as developers. For the users, we still had this announcement thread going on, and we were like excitedly posting these progress screenshots, and everybody was like, huh? What are you talking about? Are you just messing with us? But no, these are actually big steps, because when you have nothing, every single progress towards anything is already a big leap forward. And so I really had to calm expectations there and say, hey, okay, look, folks, this is just going to be boring news like this for a while, because as a matter of fact, we did not have access to physical games. Like, obviously, we had cartridges, but we did not have a mean to dump them or even decrypt them, which is a prerequisite to actually do anything interesting. So yeah, fast forward to December 2014, we finally did get our hands on decrypted titles, and we could finally throw them in the emulator and see what happens. Generally, what happened isn't a lot, probably just a hang or a black screen or even a crash. So we had to fix a couple of issues, but eventually we got somewhere. So some titles started submitting command lists, and we could see there's actually valid texture data in there. We even got to the point where one Zelda game rendered the first frame of its intro animation. Super cool. More intro logos followed. The kind of flipped screen here is a bit of a signature of early Citra builds. The Retro City Rampage got working, which is a fairly cool game. Recommend checking it out. It's also available for PC if you want. Cave Story 3D, the first title we got running that renders decently complex 3D scenes. And now I spoiled it. So after getting these things running, we were kind of stacking up the experimental patches and experimental fixes in an internal development branch. And at some point, we got far enough with these that one of the games we were really excited about started doing something. That's not this screenshot. It was just still a black screen, but I noticed it was submitting this super complicated command list, a graphics command list. And at that point, I realized, okay, it's now on me to take this last hurdle after everyone else took all the other hurdles, so to speak. It was up to me now to take that last one until we get a really big breakthrough. And so I basically pushed 1 or 2 all-nighters. Side note, don't do that. But I did. Pushed 1 or 2 all-nighters, and eventually I was greeted with this thing, which you might not recognize yet, but give it a few more hours. You see this? And finally this. And this was really the big news that everybody has been working on, the first well-known commercial game running in our emulator Citra. And of course, we didn't miss out on the opportunity. Oh no. Okay, interesting. We didn't miss out on the opportunity and recorded a video of it. It is running very slow, but that's not what matters. What matters is that it is running, because we can still tune performance later. And as we realized, eventually, it didn't go in-game at first, but if you provide it with a native save game from a physical 3DS, you can actually play the whole thing. Well, to a certain point, but you can actually get in-game and check out the first levels. That was really nice. Thanks. And so believe it or not, but we're basically past the hard part now. It is still so far from Citra being an actual usable product for anybody to actually play games on, but just being confronted with these black screens and games not booting, that is the most tricky part to get past, because you don't know in advance what the issue is. It might be any of 10 different things. The emulated CPU core might have a bug that blocks it from progressing properly. The graphics core might be trampling over some memory that the game is trying to read. There might be issues in the kernel reimplementation. There's so many things that can go wrong, and often you won't be blocked by a single issue, but a combination of multiple problems. And it's after multiple weeks and several fixes stacked together that you only really get to the point where your game really does something. And so what followed after is more or less a straightforward process. The features that we implemented are still tremendously difficult on a technical level and challenging on a technical level, but it's more or less clear what needs to be done, right? And so just as an example, I picked three specific things from the graphics side, the audio side, and the software side, just to give you an idea of what exactly we were up to there. The first thing is, and you're gonna love the slide. Yeah, okay. And you're gonna love this slide, is lighting. So as anybody who has if any one of you has worked with 3D graphics, they will know that lighting is really essential to creating this illusion of objects being three-dimensional in space. If you look at the leftmost graphic, this could be equally well just a sketch on a 2D piece of paper, but it's only once you really add those gradients and specular highlights that the whole thing looks somewhat like a physical object. And throughout the decades, academia has come up with multiple different approaches to compute these lighting formulas, to compute these lightings with formulas, mathematics. The simplest known one is the Blin-Phong model. That's super simple. But there's also, and don't be scared, more complicated things, and more complicated things, and more complicated things, and more complicated things. I love the last one, which has an integral, because why not? So, and if you are designing a GPU and you need to commit to one of these models, because the GPU designers at the time knew that lighting per pixel is really a prerequisite in 2011. So they had to pick one of these, but if you pick the least complicated one, it might not look good. But if you pick the most complicated one, your hardware might not be able to compute it at 60 frames per second. So the designers employed a trick, and they basically squinted really, really hard until all of these basically looked like the same. And so they came up with this really gigantic, complicated formula that encompasses all of the previous ones. They employed a trick, all the nonlinear factors, they put these into lookup tables. So it's just a linear combination. Okay, I'm just nerding out here. It's just a linear combination of lookup tables and dot products. So that makes it really, really easy to implement in hardware. You might imagine from an emulator perspective, from an emulator developer perspective in particular, if you don't know this formula, how are you going to figure it out? Luckily, we didn't need to do that because the GPU designers had this academic background. They actually published documentation on this whole lighting pipeline as an academic white paper that any one of us can access. And so we knew the formula, and we knew what each of the terms, so to speak, means semantically. But what we still needed to do was to figure out how all of this maps to hardware in terms of registers and how exactly the values are represented, that sort of thing. So it wasn't easy, but easier than you might think. And once we got past that point, well, now actually, what the whole thing addresses is what you see in many games is the characters will just show up as black because they're not lit. And you can't see them. Sometimes in some games, it would even be completely black. It would seem as if the game crashed, but actually just none of the objects had lighting on them. But with lighting implemented, you see the characters like they're supposed to look like. Some games, this was really extreme, especially at nighttime effects, because you can see this very stark contrast here at the top. Please, thank you. There's very stark contrast at the top between the dark night sky and this really overly bright town, whereas with lighting implemented, the whole picture looks a lot more balanced, like it's supposed to be looking. So that's it for lighting. Another thing I wanted to talk about is audio. Audio is super interesting. What's happening is that the CPU, or the emulated game, is not the one actually computing all of the audio effects itself. Instead, there is this dedicated firmware program, yeah, this one, this dedicated audio processor that's running a firmware program, and the emulated game is in constant communication with this program to send it the input audio data, the effect configuration, those sort of things. That's what's happening here. On this side, but this is basically just a protocol that they communicate with over. What the firmware program was then doing, it's outputting the raw audio samples somewhere, and those get sent to the speaker eventually, where you can hear them. So for us as emulator developers, this was already also a really tricky part because we did not actually understand how this DSP works specifically. There was no information about the instruction set, and reverse engineering all of it on top of implementing the actual emulation would have been absolutely like dragging out for way too long. So that was out of the question. What we could do instead is replace this entire blob of code with a blob of C++ code. And we did this by very carefully analyzing and observing what was happening in this memory block here. So we essentially reverse engineered the communication protocol itself rather than the firmware that is handling the communication protocol. This work was mostly done by Mary Mage in the beginning, so shoutouts to them for really doing a good job on getting the initial audio supports that were working there. Oh yeah, and it's 4,000 lines of C++ code in total, so it adds up to a bunch. Some buzzwords there are bytecode filtering, ADPCM, and AEC decoding, so as you might imagine, it's quite a lot. One third example is crow support. We're not talking about music, but rather, if you look into the file system of Pokemon, there are a lot of these suspicious-looking .crow files. They're like, particularly, there's a .battlecrow, a gameover.crow. And what this is doing is the 3DS equivalent of what shared libraries are on Linux and DLLs are on Windows. So they can be used to dynamically load code into and out of the process when they're needed and when they're not needed anymore. So rather than sharing this code between processes, this is really about saving resources. You don't need to load all of the data of the game over screen when you don't need it. So the game can just not load that data and instead do useful things with the remaining memory that is available. If you try to decode those files, you will be disappointed because they are insanely difficult to parse correctly. In fact, Wai Wang has created a diagram illustrating how it works. It's not great. So basically what's happening is there's tables in those files. Those tables contain offsets that reference all other tables. The tables are grouped into modules. The modules also have something called segments, and the segments cross-reference other segments, and everything is just a mess. Imagine having to figure out how all of this connects together from looking at the disassembly of a crow loader and having to re-implement it accurately in C++ code. Because if you make any mistake in this complex logic there, your game might just not be working anymore. Wai Wang did it anyway. 3,000 lines of code. They got it working. It's pretty impressive. And there's some notes there if you want to check them out. And the fruit of that labor is Pokemon X and Y. Oh. Is Pokemon X and Y running in Citra. Yeah. And this thing had audio as well, but we disabled it for when recording the video because, as you can see, it's running really slow, and that would have made audio really stuttery. So it was working, but we just didn't enable it. There's more. I skipped like so many things, and I really shouldn't, but we do not have the time to discuss more, sadly. We implemented all sorts of different hardware features, from like all of the different things that this GPU can do and all of the 3DS-specific extensions to OpenGL. We implemented peripherals like the camera and the microphone. We implemented decryption support, which is kind of nice. We implemented some convenience features like cheats, snapshots, and mods. And we made the whole thing faster, of course. We implemented a just-in-time recompiler from the native ARM code to x86. Shoutouts to Mary Mage again. We implemented more of the graphics pipeline rather than using a software renderer in OpenGL, so using the host GPU. And we implemented faster ways to access memory operation or to perform memory operations. So yeah. Overall, Citra was really shaping up to be quite a usable thing. Unfortunately, not everything was great. So if you look at the contribution or the graph of contributions on GitHub, at first glance it kind of looks good. Kind of looks like a healthy collaborative environment. But if you peek forward to around 2021 and 2022, you see that contributions really have slowed down to an almost standstill. And even if you look at the time range between 2018 and after, it kind of looks active, but if you look closely, it turns out there was only a single developer really doing meaningful work on the emulator core. So it's really anything but this kind of healthy collaborative environment where different people pitch or bounce ideas off each other. It was really just a one-person show at times, and eventually just no progress was happening at all. It's a little bit, one needs to speculate why that is. I think personally there's two factors. And the first one is that a large part of the team back then were kind of subscribing to a little bit of a hype-driven development culture. So the idea was we want to attract new people to the project, and what's the best way to do that? Just constantly break the news cycle. It was an idea, it was tried out. I don't think it actually worked in practice. Like, I don't recall us announcing Pokemon support and all of a sudden 5 developers joining the team. In contrast, though, what happened is that people really burned themselves out trying to reach those internally imposed deadlines to release new features, and in turn also sacrificed proper research on the hardware implementation details and other longevity aspects. So whenever you wanted to implement a new feature, you kind of had to walk over 5 traps that you laid yourself when you were taking shortcuts previously. I think to this date, there's not a single subsystem in Citra that hasn't been rewritten once or twice at least, simply because so many shortcuts had to be taken at the time to really meet these, to make the news, basically. And this is basically one of the main reasons also why I eventually in 2016 decided to more and more distance myself from that project and work on my own emulator, which for full disclosure, I wanted to say that. What I didn't see happening quite was something more ugly, and that was that Citra developers were more and more being antagonized by its user base. So because Citra progress seemed so promising, users really had inflated expectations of what the program would actually be able to do. So some users went as far as saying that emulator developers clearly were purposely adding bugs in the emulator so that Pokemon wouldn't run at 60 FPS on their 10-year-old machine. Which, considering that Citra was even able to run Pokemon at like a reasonable performance back in the day, that is something that should have been credited. But no, the entitlement was always that it needs to be perfect. For the social media maintainers, this was really a nightmare because people were really spreading a lot of hate, attacking developers. And compared to other projects like Dolphin, for example, where there was a bit of a shared social media team at some point, or an overlap in the social media teams, Citra just was stressed that people didn't want to have in their lives. There's a really good article written by JMC about this that I also recommend checking out that goes into a lot more details about what happened there in details. This kind of conflict between users and developers created a kind of vacuum that was quickly exploited by people who were seeking attention, I suppose. Pablo, one of the later Citra developers and also a well-known mod developer, summarized this as follows. So what these people ended up doing is, step 1, they downloaded the Citra source. Step 2, they changed the name to something else. Step 3, they grabbed commits from people who actually know what they're doing, but they hadn't integrated their work into the mainline branch yet, so it was just lying there. Step 4, add 1, 2, or 3 hacks on top of it that make Pokemon run better and break everything else. And then 5, claim that everything is better on your project. And sadly, step 6, it actually worked. People bought it. So these people just basically collected sources from everywhere and then hacked it up together and didn't even respect the license of Citra, which is GPL for the record. And you can see how, as a developer, this is really, really demotivating when you're working your ass off for months to get something in people's hands, but you're not merging it yet because you really want it to work solidly across the board, rather than just in 1 or 2 games. And so you do this work, and then other people take it over and steal all the credit from you, whereas you just eventually get the issue reports from people who are using that incomplete work. So that was a really messy situation, unfortunately. It's just not sustainable, and I think it's also a major contributing factor to the decline in contribution activity eventually. In 2023, it looked like things were up for the better again, but sadly something different happened. I'm guessing most of you noticed this. Nintendo sued Yuzu, a Nintendo Switch emulator, and they didn't go through a whole lawsuit. I think they settled out of court, but what eventually happened is that the project Yuzu was taken down in its entirety, so that includes the GitHub, the Discord, any kind of guides they had. Why did this happen? Well, Yuzu got a little bit too popular for its own good, especially around the time a popular Zelda game got released. These are the stats from their Patreon. And what does all of this have to do with Citra? Well, the person who was leading user development, Bunny, was also the person that I created Citra with back in the day, and the legal entity that they set up to manage Yuzu was also used to manage Citra eventually. So this takedown of Yuzu indirectly also affected Citra. There are some efforts to revive Citra these days by Pablo and another person under the name Azahaimu, which I pronounced incorrectly, sorry about that. It's unclear what will happen about this, but as for Citra, this was pretty much the end, and it really had a chilling effect on the developer side, where a lot of people quit what they were doing or looked for another task simply because they didn't want to deal with this kind of legal threat. So I thought at this point might be a good opportunity to put emulation aside for a moment and look at other things that happened in the preservation community. And the first thing that came to my mind when preparing these slides is the Miiverse. It turns out there's a really cool archive online called Archiverse that scraped all of the Miiverse for these cute little drawings that people made and cool screenshots from various games that they posted, and put them online again. So even though the Nintendo network and the Miiverse are not accessible anymore, thanks to Archiverse, we still have that old valuable content. There's an undertaking called Pretendo that hosts a couple of services, but one of them is a continuation of the Miiverse. And there was a small application for the Nintendo 3DS called Flipnote Studio, which allowed people to create their own little animations, which you really ought to have seen one of those, but I can't really play any of them right now. But this was popular enough that there's not one, but even two preservation efforts here. So there's Flipnote Archive and Kaeru, which both aim to preserve previously existing content and create replacement services for sharing content nowadays. Speaking of Pretendo, Pretendo understands itself not only as a Miiverse replacement, but rather as a replacement for the entire Nintendo network, which is, again, taken down nowadays. So if you want to trade any Pokemon or you want to play a round of Super Smash Bros., you can still do that today thanks to the work of this community. There was one particularly noteworthy anecdote that I found quite cool. That was from the Colors 3D authors. They were also affected by the Nintendo network shutdowns because they had a feature to share the drawings that you would make in this application. But when you launch this title nowadays, you get a message saying that despite the shutdown, we will continue operating as normal. And how is that possible without the network? Well, it turns out the actual developers of Colors 3D collaborated with this community effort, Pretendo, to integrate Pretendo officially into their application. So cool. So huge shout out to the developers of that application for actually going that extra mile to the benefit of their users. And yeah, if you want to learn more about Pretendo, they have a website and they have all sorts of projects in the works. So yeah, take a look. The eShop has been taken down as well, unfortunately. The eShop has been taken down, unfortunately. And as I'm sure you're well aware, there are tons of efforts to preserve the games themselves. I cannot go into detail about this for obvious reasons. But what I've done is I wrote a little scraper application to archive the metadata of eShop entries. So if one day we want to revise the eShop and like actually show people what kind of descriptions games were advertised with and what kind of screenshots and trailer videos were there, that data is still available on my local hard disk. But it exists. And I think actually that other people created personal archives as well, so who knows what will happen in the future. And there's another really cool project, Arctic-based, that I recommend checking out, but I think I need to skip that one for time constraint reasons. If we look at the homebrew community, what happened in the meantime, as I was mentioning before, we have the homebrew launcher nowadays, very powerful tool to run your own code. Some people have come up with really cool applications to illustrate the power of the 3DS graphics chip, for example. We have much more powerful exploits nowadays. Basically, we have total control over the system. We can run a custom firmware. We can dump and decrypt virtually any content, any file on the system. And notably, we even have access to the crypto keys. And that is really, really quite something. Now, what happens in the future in terms of emulation, though? Because as I was mentioning before, I quit Citra development in 2016 and restarted under a different umbrella. And the whole idea here was when I'm already starting a new emulator from scratch, what lessons have we learned? What can we do better? Has anything changed? Has any precondition changed that might allow us to do things differently that were not even possible before? And so, yeah, obviously there's a couple of lessons learned. Just don't repeat past mistakes, basically. We also have more access to native content, like the home menu or the software keyboard. Like some games prompt you to enter text and call into a specific applet for this. And like all of the different service modules that are used by these applications and that you don't normally see as a user. So we have access to all of this. And also we have a much better understanding of physical hardware. So we actually have a system now that documents and tries to emulate the audio processor. Again, thanks to the work of Wai Wang, really amazing person. This one was integrated into Citra, but because it is more used as a reference platform, it really slows down emulation from 60 FPS, solid 60 FPS, to something like 5 FPS. So it's really not useful for actual gameplay. And we also figured out everything about the GPU. Here's a diagram that Wai Wang created about every single GPU feature there is. You can follow the link to look at it yourself. My slides are bugging out. There we go. So let's look at what that means in practice. We are looking again at the software stack with the kernel and the various service modules. What Citra was doing back in the day is that it emulated all of the components that were sitting underneath the games. So you basically just had the games emulated on top of a huge pile of C++ code, whether it was hardware, whether it was services, or the kernel. This is not really necessary anymore these days because we do have access to all of the lower level components. So one question that you might ask yourself, what happens if you focus on emulating the hardware instead and try to get it as well implemented as humanly possible and instead run all of the other components on top of that as native code? So you get this hugely complex system of binary blobs interacting with each other, but as long as your hardware is implemented accurately, it should just work. And this is something that an emulator called Corgi 3DS actually did back in the day, successfully so. It was able to boot the home menu and run various games. The big problem of it is that it's very expensive to do. So emulating a kernel on its own is hugely complex already. But then if you throw in a security core processor and you need to emulate the timing between its communication with the main processor, that gets super tricky and is basically impossible to, I mean, never say never, but it's really, really difficult to achieve 60 FPS at that point. So what Mikage is doing is kind of a middle ground to get the best of both worlds. I do implement the hardware very accurately, but also the kernel and the security processor are abstracted away as C++ modules. So these ones I still have to reverse engineer and figure out and re-implement, but all of these 50 or so service modules on top of this, I get those for free. And that allows a lot of really cool, useful opportunities that I'll get back to in a moment. But to make this concrete, for example, remember this complicated crow diagram. So crow is actually decoded by a service module called loader row, which you can see here in the diagram. This is something that Citra had to re-implement with this 3,000 lines of code patch, whereas Mikage, thanks to going one level further down, we can just run the native loader module. When we try to do that, we have noticed one thing. There's one system call that is specific to the loader module. It's not used by anything else. So we do need to implement that one. But that only takes 80 lines of code. As you might imagine, 80 lines of code are a lot easier to reverse engineer and get right on a re-implementation than 3,000 lines of code. So not only did we as developers save a ton of effort on virtually every side here, we also made the user story better, because this thing will run much more reliably than the 3,000 lines of code on the left, simply because we do not know what bugs might be hidden in there. So the distinction between those approaches, that's called high-level emulation versus low-level emulation, and it will come in relevant in just a moment again, too. But first of all, I had a demo that I prepared, and I'm afraid the setup woes in the beginning threw me off a little here. But let's see if we can get it working. Fingers crossed. Well, that's promising. Yeah, so due to time constraints, I'm afraid we will not be able to fix this. That is a little bit sad. Let's try something else. Okay. So this is a fault. No, this is not gonna. Oh, okay. Okay, I'll take that back. So by pure accident, Pokemon Sun and Moon are actually working after all in this demo. And but sadly, we don't have time to actually play it, so. But yeah, that's also thanks to Crow support, because Pokemon Sun and Moon are absolutely blocked by Crow, and they will not do anything without it being implemented. So having those 80 lines implemented was like a super big payoff here. But let's go back to the previous slide, because one other thing that I skipped over here that this enables is that system software is now supported out of the box. And this will be the much cooler demo, because let me show what you can actually do with this now. So what I will show you is the very first thing that you see once you configure and boot up Mikage for the first time. So you get the actual initial setup screen running in the emulator that you just set up. And I need to... So I'm probably going to cut this short, but what I wanted to show here is if you complete this, you can enter the home menu. You can even shut down the emulator. Maybe that one actually works. No, it doesn't quite at this point. So yeah, you can boot the home menu after this thing. You can play games. This all works out of the box. I think this is really part of what makes this emulator great compared to Citra, where setting this up also works kind of because they brute force this, the implementation of this. But in Mikage, it's just all of the out of the box there. And so let me give you a little overview of the various emulators that we have nowadays. So as we discussed, we have this high-level emulation and low-level emulation in comparison. Oh, no. Citra is a high-level emulating emulator. We had Corgi as an example of a low-level emulating emulator. There's also Panda 3DS, which is also more in the HLE category. It kind of works the same as Citra. It doesn't really fundamentally do anything different other than throwing a lot of Panda memes into it, which, fair. It's more of a project of people coming together and having fun tackling cool challenges, and that's totally fine. I would say that this diagram opens up a second dimension, though, of comparison, and take this with a grain of salt, especially if you work on one of these projects. But I would consider the bottom two projects more of tech demos, because going from an emulator code to something that people can actually use and want to use by writing extra guides, for example, by having convenience features, that is something you need to do on top of the bare minimum, and it's often just not all that fun, to be honest. And Citra really prioritized this from the very beginning. And so this glaring gap there of a low-level emulator that is user-oriented, something that I'm hoping to fill with Mikage. And coming back to audio, how does it actually look like in this case? Well, remember, we had the actual 3DS, the actual DSP firmware that we couldn't really look at before, and instead we re-implemented it all in C++ code. Well, it turns out nowadays that we understand how the DSP is working, we can actually emulate this thing. We had TechWare back in the day, so this DSP interpreter, which was really slow. But what I actually came up with is a recompiler that takes the native DSP firmware and recompiles it into one huge blob of x86 code, which then talks to the emulated game. So you don't need to implement any of the audio algorithms. I love that I did not have to learn audio algorithms. Anything that saves pain in this brain up here is always welcome. This was not an easy task. There's a couple of very difficult issues with this DSP that I can just rush over really quickly. There's a stupidly huge instruction set with over 400 decoding patterns. The instructions themselves are ridiculously complicated because they're optimized for DSP use, and that just happens to be very beneficial, but really difficult to emulate. This is one instruction this year. We couldn't even figure out a decent disassembly syntax because it just does so many things. And then on top of that, there's configuration registers, which the firmware toggles at compile time, and in contrast to enabling simple binary behavior, this actually changes the behavior of individual instructions in significant ways, which makes emulating them efficiently really difficult. So again, shoutouts to Wai Wang for reverse engineering this all and writing a reference implementation for it. How did I make this fast? Well, basically, I just implemented a traditional recompiler first by implementing a control flow graph reconstruction, basically a static firmware analysis, if you wish. I then employed a compiler framework called LLVM, which many of you will probably know, to translate all of this firmware into an intermediate representation, which then the LLVM project is able to translate to x86, even RISC-V if you fancy that, so whatever is running on the host. If you do that, it will still not run full speed because it just doesn't. So I implemented this really, really cool profiling integration, which actually tells me for every single block in the firmware program how much time it's occupying, so I could identify bottlenecks very easily and figure out what to optimize next. And thanks to some other magic tricks, which I cannot talk about, unfortunately, because I do not have the time, it eventually was able to keep up performance at 60 FPS. So you've seen the demos before. They had audio enabled, and it was running at full performance. And this is really the final point that I want to make here. I don't settle for good enough. So I want this thing to really be a perfect simulation to a reasonable degree where games actually rely on it anyway, a perfect emulation of anything that a game might expect to happen. And to do this reliably, I actually went and created the first fully automated test suite for 3DS APIs. I even implemented a concept for graphics testing. So this is what that looks like. It looks like it's just rendering one rectangle. Actually, it's rendering about 10,000 rectangles per frame. Each of these covers exactly 1 pixel, and they're just stitched together in this one big rectangle. What this allows me to do is it basically allows me to test 10,000 input configurations to the pixel pipeline in 1 frame. And so you see at this summary here, there's 100,000 tests that were run in those 10 seconds of the video. So this is really, really powerful if you want to understand how the different how the different elements of the pixel pipeline work together. And on top of that, I bundled this whole thing with a tool that enables reproducible builds on for the Nintendo 3DS. This is unfortunately something that's lacking in the main homebrew toolchain, and which I basically had to invent myself to cover that gap. But the point is, it's really essential that the tests that you write today still run the same way in 10 years. So you wouldn't want a change in the core library to somehow influence test behavior. Right. And so the ultimate goal on a technical level for this whole project really is to bring low-level emulation to everybody, to the mainstream. So we've seen from the research perspective, Citra has kind of taken the brute force approach, is re-implementing the world, which also means it needs to reverse engineer the world, whereas I'm really focusing on a minimal attack surface that I try to get working well and get to working reliably and test deeply. As far as correctness, things just work for me, whereas Citra kind of employs a lot of playtesting, or used to employ a lot of playtesting and code review solely. There wasn't really any automated testing employed as far as I'm aware. For content, we can say that Citra mostly focuses on game emulation. You can get other things working, but you have to go out of your way to do it. For Mikage, it's all built in. Audio just works. Citra has some issues, particularly with rhythm games. Graphics get bit-accurate results in many cases for me, whereas Citra, as far as I'm aware, has no structured way of doing hardware testing. This is the technical side, which I believe makes developer life a lot easier. From a user side, what I think is really the compelling story here is the trifecta of content, games, and system software, online services, online multiplayer system updates, because why not? And hopefully eventually we'll bring back the eShop as well. And as a third pillar, the community content, the Miiverse in particular. It's not entirely clear how we're exactly going to bring these things back, but the idea is really to not just focus on the games here, but really on the entire experience that made the platform what it is. I didn't actually mention the downside of this all. I haven't actually released the emulator yet. Can't actually use it today. And I think the slide I had previously about the downfall of Citra and the things that discouraged developers from continuing to work on it, they kind of explain a little of why I chose to do it this way, I hope. And it's still going to be a while until basically people stop comparing Citra to Mikage. I really just want this thing to be its own experience because it really is. And once it reaches sufficient feature parity with Citra, that is when we will consider releasing it. But I do not want to leave you empty-handed. So what I'm releasing today, and this is a really big step for me, is a majority of the emulator core. This is really the one sentence. This is really the huge thing that I want people to gather together and finally get us over the edge to improve compatibility and get Mikage over the edge to really compete with Citra in a reasonable way. It doesn't contain any of the convenience features you'd expect from a user-oriented emulator, but this is really where other people can now join and finish this thing. There's also a Matrix community. Send me an email and you get an invite. And since we're clearly out of time, thank you so much. And yeah, I'll be on stage for another few bit. Thanks again.
Thank you very much for your talk and for the loud applause. I think most people here can't wait to get their hands on Mikage. And yeah, thanks for the wonderful talk.